We will be discussing a very popular mergesort algorithm in this video. As usual, we'll go through some theory first, then we'll implement mergesort in Python, and in the end we will have an interesting exercise for you to practice on. Let's say you have two sorted arrays like this and you want to merge them into one single sorted array. Now you will be like, why are we talking about two sorted arrays? The whole goal of sorting algorithm is to take unsorted array and create a sorted array out of it, right? Well, hold on your thought. We'll get to that later. For now, just think you have two sorted array. You want to create one single sorted array out of it. How can you do that? Just pause this video and think about it. It's actually quite simple. So you start with the first element in each of this array. You compare them. The smaller one is 4. So you put that smaller element into your sorted array. Then you keep the pointer at 7 as is. And in the second array, which is on the right hand side, you have moved your pointer to next element, which is 9. Now you compare 9 with 17. Which one is smaller? Well, 9. So you put 9 here. And after you put that into sorted array, you move the pointer. So now you are at 25. Now you compare 17 with 25. Which one is smaller? Well, 17. You put 17 here, and now you move the pointer on the left array. So now you are at 21. You again compare 21 and 25, put 21 here. You keep on doing that and you get this nicely sorted array. So what we learned is if we have two sorted arrays, creating a single sorted array out of it is very easy. So now let's go back to our original problem, which is we have totally random unsorted array. How can you sort this using the concept that we just learned? Okay, let's try this out, okay? Just for an experiment. We divide this into two arrays. So we take first 4 elements, next 4 elements, make it half and half. If you have 9 elements, you can do 4 and 5, doesn't matter. Then now you have two arrays and you try to merge them. But well, I cannot merge them easily using the techniques I just learned because these two arrays are not sorted. So then what if I try to divide them again? Now can I merge this 2138 with 2917? I still cannot because these two arrays are also still not sorted. 21 and 38 is sorted, but 29 and 17 is not sorted. All right. So then you move to the next step, which is you still divide them. You might have known about divide and conquer and using recursion, and that's exactly what we're doing here. Now we have all the arrays with only one element. This array has only 21, this has 38, and so on. Now can we merge them? Well, yes, now we can because an array with single element is already sorted. So now we can use our technique that we learned initially and merge them. So let's take this 8 arrays that we have. Although they have single element, they are still arrays with single element. Now we go back, take 21 and 38 and try to merge them. Well, we can merge them using the techniques that we learned initially. Same thing with 729, it looks like this, 425 looks like this, 932 looks like this. Then you go to the next step. So see, now when you merge these two arrays, 21, 38 and 1729, these two are already sorted. So you can merge them using the technique that we learned and it looks like this. Similar thing is happening here. And then you sort these two as well into the array. So now you realize that by divide and conquer, we sorted our original array easily. Yay, I know what is divide and conquer, yeah bro. Okay, The time complexity of this algorithm is order of n log n. If you want to know how we arrived at that complexity, I would suggest you read this article on Khan Academy. Our original divide operation is order of 1 because it's a constant time. Then the combine step is order of n, and then the actual merging part is merging and sorting them is n log n total. So just read through it, you will get an idea. Now merge sort is an important algorithm because it is used by Python's sort function. So when you call sort built-in function in Python, it uses a technique called timsort, which is a hybrid algorithm that uses merge sort and insertion sort. So you realize that merge sort is quite important. It gives you a very good time complexity. We saw like things like bubble sort takes order of n square, which is a lot of time, whereas merge sort takes only n log n, which is quite fast. Let's go get into Python coding now. First thing I will do is write a code to merge two sorted arrays. So I have written this empty function and I'm passing two sorted arrays. So let's finish this function first, then we will write the code for merge sort. So as we saw already that we are taking two sorted arrays and creating a third array. So I'm just gonna call it sorted list and I will return that whenever that sorted list is prepared. So here we'll be writing that code. The thing you need to do is first get the length of both the list A and B. Okay, and then you will iterate through both the list until you reach end of either of them. So you will say while I is length, and we just have two pointers, I is equal to j is equal to 0, and you will say length of b. You're doing this because you want to stop whenever you reach the end of either of the list. Now you first check you compare the element from both the lists, right? So you say if a of I is less than or equal to b of j, which is in the second list, you have a element which is higher than the first list. So now you will put this particular element in a sorted list. So you will say sorted list dot append, and append you put a of I, and then you of course increment I, right? Because you are inserting element to sorted list from A, that's why you are only incrementing I. You are not incrementing J because your J pointer is still static. If you look at our presentation, you see if you are inserting 9 from the second list, you're not touching your pointer from the first list. So whichever list you insert the element from, you only move the pointer of that. So right now, this is I, this is J. In the else, you find that the element in the other list is less than this first list. So you will now put that element in your sorted list. So you will say append b of j. Guess what you need to do here? Well, you need to increment j. All right, so I think the logic is kind of done. We iterated through both the list, and from each of the lists we are maintaining the pointers, which is I and j, and you compare the element one by one, and whichever element is less, you put it into sorted list and you return that. So let's execute and see what happens. Okay, so looks like it worked. 5, 7, 8, 9, 12, 45, 51. Oh, I see 56 missing. Any guess on why this happened? Well, I think what happened was we reached the end here. Okay, so let's say this condition. So we reached the end, and when you reach the end, just because you have end condition, this for loop will exit. You can also have scenarios like this. And see, you will now miss all those elements. After this for loop exits, you will miss all these three elements. So we need to run one time loop on both the list actually. So what that loop will do is, so you will say, okay, after I have exited this loop, which means either this was true or this was true. If this is true, then I need to iterate through rest of the elements from this list and just directly append them. So I will say I is less than length of a sorted list dot append a of I, and then I'm incrementing my I. And you want to run the same loop for the another list, which is your B. So here you will say B, this is B of J, of course, and here you are incrementing J. I hope you're getting the point. If you don't, just put a breakpoint in your PyCharm and run it. I'm using PyCharm Zen mode. That's why you don't see any distraction here. All right, so we have the function ready which can merge two sorted lists. Now we need to give our real list. So I'll remove this and I will give an unsorted array for sorting. And I will probably write a function called merge sort. Okay. So I need to implement that function. The utility function that we needed to merge two sorted arrays, we already have that. So now we are writing merge sort function. And okay, let's think about it. What we need to write here. So this will be a recursive function, as you already saw in the presentation. And for any recursive function, you need to first take care of the exit condition. The exit condition was whenever we have array of size 1, you want to exit, correct? So you will say if length of array is less than equal to 1, let's say it is 1 or 0, it's an empty list, then you want to return that list. So this merge sort function is returning the new sorted list. And if that is not the case, then you find the mid element because you divide the array into two parts, left and right. And in Python, this is super easy. Once you have the middle element, you can use the indexing. If you don't know about indexing and Python basics, follow my Python basic tutorials, you get an idea. And you get left and right. Right is elements starting from mid all the way till end. If you don't specify anything here, it means it's end. If you say 6, it is gonna be going till 5. Okay. Now what I will do is, see, I need to call, we need to call merge sort function on both the left and right array. This is how you call it in a recursive manner. And once you can call merge sort on left, you get a sorted left array. So I will store it in left and I will say right is equal to merge sort right. And once you get left and right, both are sorted, then of course you call merge to sorted list. So left and right. And you return that. Because merge sort by default, it returns a sorted array. So once you have sorted array, let's say two sorted array, when you merge, this guy is also returning it. Hence you need to return this as well. And let's try it out. Okay, mid is not defined. Let's see. Okay, so mid is nothing but the length of an array divided by 2. Now if you just do one divide, it will give you floating number. So if you do this, it will give you the integer number. See, my list is sorted now. You can see 3, 7, 10, 15. Yep. So this worked. Although this worked, this required creating new arrays all the time. You see, you are creating new array, then you return it. So it's not optimal in terms of space complexity. So what if you can do everything in line in your original array itself? Well, then that might be an efficient version of the merge sort. So let's do that. So in that, what we're planning to do is basically something like, I don't have to return anything. See, if I do this, and if I print array, it should be sorted. So you're sorting array in line. So for doing that, we need to stop returning things first of all. So here I am returning these two sorted list. So instead of creating a new list, let me remove that. What if I pass the original list here? So see, I have passed original list in my array. So let's start with merge sort function first. So here in merge sort, first of all, if the size of array is 1, I don't want to do anything. It is already sorted, so let's not do anything. And then here also, let's remove this, because when you call the merge sort function, it is sorting this left and right array in line. And once you have these two arrays, you can just merge them. So now let's come to merge to sorted list. Here I will pass an array because I don't have sorted list and I need some place to put my sorted elements. So I will do array here, and then see, here I was appending them to the sorted list. So that appending thing is gone. So here maybe I need to create a new index called k. This is the index into the sorted array, which is ARR here. So instead of appending it to sorted list, what you can do is you can say array of k is equal to a of I. So I'm just replacing this line. This line requires me to create a new list. I don't want to create a new list to save my space. So I'm just using the original array. And here I will do the same thing where I will assign b of j to something. What is that? Array of k. Okay. And in both the cases you want to increment k because you're appending element to your final list all the time. Okay. You will do similar thing here as well. So here you will do assignment from array A and then increment k. Same thing here and increment k. And you don't return anything because the inline array itself is sorted. Okay. So it's the same code as previous one. I'm just optimizing my memory usage. Right click run and you see the array is sorted. Now usually you want to run a couple of test cases to make sure it is working for all the edge cases and so on. So I always have this habit of writing different test cases, and I will do for array in test cases. So it will take one array one by one and then it will print it. Wow, so that worked. You see, check each of these lists. They are all sorted. I tried empty list with one element, list that is reverse sorted, list that is already sorted in a correct order, and a random list. And it is passing all the test cases. So hooray, good job. Our merge sort program is done. Now let's move on to an exercise. I'm gonna provide a link of this exercise in the video description below. So make sure you check the video description for the link of this exercise as well as the code we covered in the video. What you have to do is you have a list of elements which are like JSON objects. And these people are marathon runners. By the way, these people are from our Discord community. They are mostly admins on Discord community. So thanks Vedant, Raja, Vignesh, Chinmay for your awesome contribution. We want to modify merge sort function so that it takes a key, and based on that key it will sort. So for example, if you say time hours, then it will sort by time hours. So you see 3, 2.5, 1.5 and 1. Here it is in descending order, so you are also specifying descending equal to true. But if you say sort by name, then it will sort by name. See, C comes first in the alphabet and R and so on. And if you don't specify any argument here for descending, it is false by default. So do this exercise, it should be fun. Doing exercise is the most important thing, friends. I keep on saying this. If you just watch video, it won't be useful. So trust me, you do the exercise and you don't click on solution directly, okay? You know what's gonna happen if you do click it directly. You have to put your effort, you have to try it out, and after that you tally your answer with my answer. Thank you very much for watching. I hope you are enjoying this data structure and algorithm tutorial series in Python. I have a complete playlist for all data structures and algorithms, so go check it out. They all have exercises. Thanks once again. Bye.